Hey everyone, welcome this morning or whatever time you're in. And hopefully it's a good weather and a good air conditioner. Pretty hot in here. Welcome to the summer's webinar, obviously. And today we're going to talk about testing non-functional requirements. For people new to the idea of non-functional requirements, this can be an introduction to that. I'm going to talk about aspects of that. Of course, what non-functional requirements are, what it means in testing. It's not going to be as technical as other webinars that I did, but you can watch those on the YouTube channel if you go there. And I hope it will be valuable for you. I'm Gil, hi, from Testing Gil, and I'm a trainer and a consultant, and I also do webinars like this and about testing, development, and for everyone who wants to make software better. These kind of things that we're going to talk about today are usually not my bread and butter, let's say. It's kind of, and I prepared a slide to tell you that this is a lie, I don't have a course for that. When we talk about non-functional requirements, it's usually as sort of patching it up into other courses that I do from unit testing and API testing, web testing, stuff like that. And we're going to talk about this and our perception of the non-functional requirements and our perception of how to approach them, also from an organization kind of view. So I don't have a course for that, but if you're interested in a course about that, let me know. Maybe I can help you. Of course, I can help with other things that I do. Like I said, all kinds of testing and automation and clean code, stuff like that, anything that relates to better development and quality. Okay, so I'm going to start with a definition. So I asked Wikipedia, dear Wikipedia, what is a non-functional requirement? And Wikipedia answered, a non-functional requirement is a requirement that specifies criteria that can be used to judge the operation of a system rather than specific behaviors. Yeah, Wikipedia is really known for giving long answers and they're not quite really exact. So I looked for other things and I found this. A functional requirement is what the thing, the system, the feature do. The non-functional requirements is checking how well it does it. And this is a kind of a, I think it's a good definition because if you think about it, Jerry Weinberg said that quality is value for someone. And we look at the features that we build as quality for someone, like someone's looking for them, the users, but other things that are important, not just for the users, some of them are for the users, and some are not for the users. I collected a bunch of what we call topics in non-functional stuff. And you'll see that this is a very big list and probably not final. And I'm going to like go briefly about these things. So what you see on the screen, like availability, scalability, reliability, a lot of them are finished, have a suffix -ility in it. We kind of relate those things to performance, especially in cloud applications today. We always talk about availability. What is availability? You can see that these things like availability, scalability, there are capabilities, of course, of the system, but when we're talking about testing them, this becomes like, well, what does it mean? Availability could be like a binary thing, but usually it's not. Like the system doesn't go offline completely. So what is availability? What is good availability? We need to define these things prior to starting testing them. Scalability, again, it's a capability. It's an ability to grow, add servers, remove servers maybe when there's not enough traffic. So again, it's a capability. It's not like something that you can easily measure Or maybe you can measure, but how do you judge if it's good or not? Reliability, when it comes from the hardware world, there are things like mean time between failures and stuff like that, that you can look at and say, well, these are the things. We need to define these kind of things also in software world, especially in the cloud world. Disaster recovery, if you think about it, disaster recovery, it could be like a full recovery, but sometimes it's not a full recovery. Suddenly it's a partial recovery. And that may be okay. And if you think about it, it's not just like the system, it's the organization behind it. So when we're talking about disaster recovery, it's not just how long does the system take to be back to some point that it was before in terms of performance or behavior. What is the process to do that? Who are the people involved in that? And how does that impact our ability to recover? Resilience is the same. I put data integrity here because a lot of the things that we do today causes states where data is sort of invalid. And data integrity, we kind of think, oh, this is very important for us, but that whenever something happens in the system, we could take the data, either restore it from a backup, something that become and restart from there, because we're going to be in a sort of a valid state in terms of the data. That's not always the case. So these things are like either fluid, not really completely defined, but they do have a cost. Like if you think about Facebook or YouTube or WhatsApp recently, they've gone offline for a couple of hours. Like the whole world started talking about it, like in the other channels, because WhatsApp was off. So you can think about all these things in terms of application or even features, even APIs. Specific APIs are going to have different kinds of load, and we need to think about it. So we kind of think about these things first when we think about like non-functional requirements, specifically in cloud applications like web applications, so on. But there are others. So these are things like have been in systems like for years, and these are a bit more measurable, a bit more, if they're measurable, they're easy, simpler to test. I wouldn't say that it's going to be easy, but throughput, capacity, cost, you can measure these things, because throughput means like how many people requests going in, how many go out. Can actually count these things. We can, in our mind at least, it makes sense in terms of what do we do here? What do we look at? Is it working? Efficiency, kind of I'm sitting here in the air conditioner while my servers somewhere are putting out a lot of heat. So I want to make sure that my applications have some kind of efficiency built in, and I would like to know how efficient they are. Energy-wise, calculation-wise, could be a lot of things, but currently I'm kind of focused on the heat thing. And everything that we do today, like we kind of used to it already. We're talking about responsive applications, responsive whatever. And response time falls into this kind of bucket. So if you think about an API that does a thing, how well does it do it? Well, how long does it take to get an answer? How long does it take to complete this kind of operation? So yeah, these things as well. So, but these things we kind of, at least in our minds, think, oh, it's easier, like I said, simpler to test these things, because they're kind of connected to the things that we do. But wait, there's more, not this one. So there are other things, stability, sort of like resilience maybe with privacy, data privacy. We think about this thing, but what is private? How do you measure privacy? How do you know that something is private? You need to actually think about these things to qualify them, and then quantify them. And we're starting to see here like safety, security. Safety, of course, in hardware is very important. Like things can get very bloody if not, but there are other kinds of safety in the software world as well. So we need to do that, and security and accessibility and usability. And you start looking at this kind of list and you say, well, it's not only that it's hard to even start thinking about these things. This is where you're starting to think, well, this is a specific expertise, and it is. And there's a whole book of knowledge about these things. Like you probably work with usability experts, and they have a lot of experience and knowledge and know what to do. And how usable is this? And how do you measure that? Accessibility has been very relevant in this last couple of years. There's a W3C World Wide Web Committee that issued like rules for accessibility, and you once you have a rule or checklist, you can actually go with that. But you need the expertise first to create these kind of rules. Security, you need like a lot of knowledge in security, how to hack systems, like if you're hacking systems. Identify vulnerabilities, point them out, look for loopholes. That's a whole baggage of things, and some of them, and they are in different levels, right? Some of them in the code, some of them in the system. Like, need to think about this. Privacy, GDPR. Everybody has seen the flag of the GDPR and offering cookies on every site in Europe. It's like regulated stuff. It's a must, a mandatory thing. You need to understand it. It's not like just putting up the accept all cookies button and that's it. There's a book of knowledge around this, and we need to understand what we're doing. Okay, we're not done yet because I want to do another thing. And this we don't think about, even people who are aware of non-functional requirements, what they are, kind of thinking, well, what does the user see, what the final user see? But the users, like I said, are not the only stakeholders that we have. And we look, if you look about these things, and these are like sort of like internal qualities. Usually we associate it with the code, like extensible, how easy to add a feature. And it's really hard to quantify, really. Maintainability, we always look at that. Now, so is that a non-functional requirement? These are probably not things that testers will see. But these are things that testers and developers are the stakeholders of. And if this is something that is important for you, maybe you can treat it the same as the other stuff. Learn more about it, try to quantify it, and build processes to make sure that you live up to what you decide to do and maybe improve, hopefully. So, and none of these things are really, again, similar to the non-functional stuff that what the user sees. All of these things are not binary. There's no something that's not testable. Some things are hard to test. Some things are require a lot of effort to test. Some of these things require a lot of motivations to test, but most of the things are testable, like and sort of readability, and so is reusability. So it's never like an either or. Sometimes we specifically this coming from my especially for my unit testing and clean code classes, like usually people talk about this code is maintainable or not. It's never not. If you need to go in this code and fix a bug, you will do it. Same with ability, same with the testability, and so these are qualities that are interesting to the internal team. That and usually we won't talk about them too much, but if they're interesting and you want to improve at what you're doing, you probably take the same steps as you are going to do with the other non-functional, the user stuff. Okay, so yeah, there's a bit more than that actually. So, and you can like sort of classify them, pull them together in different groups, and that's okay, but that's still going to be a lot of them. That's just the way it is, and that thing's going to be like, if you think about introducing AI decisions into the product, you kind of start thinking about these things like differently. Like, okay, there are other decisions that we are not in full control of, and they are not like determinate when we do that. How does that impact all the things that the user sees at the end? So things are not even getting like larger in terms of either depth or topics, but also expanding in terms of, well, there are other things that impact what the user does and sees. So Kent Beck said, this is the guy, Kent Beck. He's one of the people who, he created JUnit, sort of invented TDD, because TDD is not an invention, but that's first. One of the people from extreme programming has what you see on the screen, make it work, make it right, make it fast, is a saying that he has about usually the code. So first, when you write the code, you make it work, do the thing. Then you make it right. When you apply it to code, it's like you refactor it or do whatever you can that next time you go into this code, you spend less time. And then you optimize it when you have both working and maintainable, manageable, readable, and so on. And you can apply it to all the features that we do as well. So first, we build features to work. And if you're in a startup phase, for example, that means that you're looking for a solution. So you don't know what you're building. So all the other things like usability and accessibility, not really priority then. So first you try to find what to build. Once you build it, you first make it work, then you make it right, make it fast. The make it right and make it fast is kind of leak into our topic today because yes, they're working. But now we're trying to answer different questions than we had before. And sometimes this is hard because guess what? We already have code in place. When we have code in place, systems in place, it's hard to move them around. So making things right in terms of the non-functional stuff, patching them correctly, it's really a patchwork. And yeah, sometimes even when you look at the code, you actually see that. So really is a process here. We're starting off with something that works, and then we start, well, how do we add this privacy things? How do we think do this? How do we add security stuff in there? And if we go by the non-limited list that I showed you, right, that's a big list. How do we do that? We first need to prioritize what is important for us. We also have another problem that functionality, like most people are used to understanding, oh, this should work. It's very simple to explain how things should work. You have this screen, you press this button, this is what you see on the screen. And the reason it's easy to explain is that we are also users all the time. So it's, even if it's an API and you haven't used an API before, I kind of think if, well, I put this into the system, this is what I get out. The functional stuff is usually easy to explain. The non-functional stuff, you need the expertise to explain, you also need the expertise to understand. So it's another challenge that we have when we're trying to like improve our product by adapting or implementing the non-functional stuff. And in terms of communication and organizational structure, in order to support that, yes, this is hard because the traditional roles of developers and testers and product, they usually, like we said, it's not the first thing that they do. And that's a problem for organization trying to tackle this. And usually organizations try to do this in different ways. So you identify, let's say, security as something that you actually want to improve on. What the trigger for that was, couldn't say. Could be something like something disastrous, something not regulation coming in. The trigger for these kind of things could be like different things at different times, but you identify that we don't have enough people who know about this stuff to specify this, or at least say, how does this look when it works? The cool thing, by the way, when you do have this, there's no distinction between a functional requirement and a non-functional requirement, because once you know what to do and how it looks like, it's like another requirement. Maybe the setup is differently, maybe the setup, it's hard to set up things to go, maybe it's harder to see how things are going, but once you know how things should look like, it's a requirement like any other thing, you can treat it the same. So usually we think about product as the subject matter expert. Sometimes we have testers that have this kind of skills and expertise. Organizations now need to develop this kind of expertise the same way. And you probably want to, or expect to, this product people to handle everything for us, but this will not happen. Like, it's enough for them to handle the functional stuff, the subject matters that they are experts in, and adding more capabilities like that is going to be hard. And this is why a lot of organizations, like when they define that this is important for us, either someone emerges to say, okay, I'll take it on me or on myself, or the organization says, hey, you do that. That happens a lot as well. Especially when things like are cross-product, like GDPR, for example, like all the web products that we have need to support GDPR compliance, have to be compliant. So we probably need one, maybe more people that can be cross teams and help hold this expertise and give the guidance, so on. Usability is the same, and this is why a lot of the times you'll find like one person, maybe two, as the local experts on these things. And it's good when you do that, like you actually grow people, and we'll talk about this at the end. This is a very good opportunity to become not just an expert, good for your resume as well. From an organization point of view, though, organization need to do the balancing between, like, we can't have everyone know everything, obviously. So there's going to be a security expert, there's going to be a usability expert. But this is what we call the bus factor. Like, if someone gets hit by the bus, does the organization stop working? So organization need to balance these things. Like regular knowledge, the same applies here as well. So most organizations do either grow these or they bring experts from the outside, although they usually bring them for short-term time. They transfer the knowledge as much as possible internally, and then you have people who become, over time, the experts on these things. Once you have this kind of expertise, you can start defining like the boundaries, what you're going to look at, why is it important. Some of the things are really easy to look at. We always think about performance as a non-functional requirement, and we have like a load and stuff like that. We have tools for that. We'll talk about that as well, to create load or simulate load. But when you start out, you kind of probably want to know where you are. It's easy to say we want availability of, I don't know, 5 nines, whatever that means. But yeah, okay, how are we today? Maybe where we are today is good enough. So usually you start by exploring where you are. You kind of build it, or you're not really testing against a requirement, but you try to understand where you are today. Build a series of experiments to say, okay, if we're doing, let's take the load again, because it's usually people understand it. Let's run this with 100 users a second. Let's run this with 1,000 users a second. Let's run this with 1,000,000 users seconds, and see where we are. When we have these kind of sort of results, we'll talk about the quality of these results in a minute, we can at least say, okay, are we in a good place? Where do we want to go from here? So we start off both by understanding where we are in terms of things. Sometimes it's simpler, sorry. You have a checklist. Sometimes it's not. So once we understand where we are, we kind of need to define what our metrics are. How we're going to measure this, how we do it. We're going to do these experiments. We need to say, okay, this is what we're looking for. And this is probably what we're going to do with it. Probably at this stage, like you probably don't know. And you don't want to commit any decision anyway, because you don't know where you are. So this is the results. This is what we think they mean. Testing. Now, I'm guessing some of you already saw this somewhere in your testing lives. It's called Agile Testing Quadrants, and it has nothing to do with Agile, except for the person who created this, Brian Merrick, and who was part of the 17 people who went on to write the Agile Manifesto. It doesn't have to do anything with Agile. He sort of like said, oh, we have all these kinds of testing activities. Let's throw them into quadrants because this is what managers like, and see what happens. For us today, what's interesting is what happens on the left and what happens on the right. On the left, there are things that are supporting the team. And on the right, the critiquing the product. Let me translate that. The supporting the team things is the testing or testing activities that we do before release. Any release. It could be like feature or whatever, but any release, we do that. So we're doing some kind of testing. And we look at it, and basically we look at the results and say, okay, this is ready for release, not ready for release, and so on. Oh, unit tests passing. That means we can run a different set of tests on it. Like let's run the API test because all the unit tests are running. But on the left, that means that the teams are looking at the results and deciding what to do with it. On the right-hand side, it's like user actually using the system. And you can see that you can't really automate stuff on the right hand because like you can't automate users. You can try, probably not will not work. So you have to let actual people use your product, something like that. This is the right hand stuff. What you have at the bottom though, where it says performance and load testing and security testing and utility testing, that's starting to sound familiar. Why does it have tools attached? Well, there are a couple of questions, really. First of all, not everything has tools in it, but a lot of the things can be, at least you can test with the aid of tools. Load testing, JMeter, stuff like that. You can create load. All kinds of things in performance that you can measure can be done by tools today. If you're running things in the cloud, you have a lot of monitoring that can be done. Security testing, we'll talk about this in a minute, and all the things that we talked about. And another question that comes up, that obviously some of the things cannot be done with tools, like usability. Is it usable? If it's usable for a robot, maybe okay if that's the target audience, but if it's not the target audience, probably can't think about this. Why are we doing this on there? Why are the users doing this? So it's interesting because I would like to know about if we're in the range of load testing or load benchmarks or performance benchmark before we release that. And we can think about like testing we do before and testing we do after, but what we're doing today is really, we can't drop this on the customer to do it for us. We have complex system today, and we'd like to know everybody wants to shift left, right? What does shift left mean? I'd like to do things that I can do in production, maybe before that, in a stage environment. What I can do in a stage environment, maybe I can do before that, so I can know where I'm going. So it's not completely accurate or modernized, let's say. At least some of these things can be done earlier in the process. So let's talk about that. What can we do when we're like early in the process or the day? This guy needs coffee. So things that we can check like early in the process. Early in the process means that it's still maybe even at the developer's hands or in the continuous integration pipeline. Things that we can check there. And I mentioned checklists because checklists are important. If you have them, and maybe you can automate them, you can run them frequently early in the process. And I'm going to give you an example of you have things like security in code, code vulnerability, stuff like that, that fall into the security bucket of non-functional requirements. Well, if you have like things like tools like code scanners, SonarQube, stuff, something like that, they come with a checklist of these rules are important for your code to behave this way, because there's a thinking here. If this code has this vulnerability in it now, it will continue to have this vulnerability when it goes to production. So if we can find it earlier, great. Some things we can't do that. We'll talk about those in a minute, but we're trying to see where we are in the process and see what we can find, and things like that, like security, accessibility. Like I said, there's a checklist. It's a checklist somebody went on and implemented. I showed in a former webinar the X framework, the X library for checking accessibility violations, and you can run them on your page, part of your build, on every page, and you can get all the violations that you've done on purpose or not on purpose, in terms of font size and contrast and all the things that are already specified that can be checked early. You don't have to run it like every day. Weekly, you can define what you want, and depending on how easy it is and how scalable you want it to be. But you can do this. Data safety, you can actually check if things that are accessible through application. I'm not talking about configuration of the database and users and stuff like that outside your code. Things in the code that you have applicative security or safety, you can check these things early. Obviously, with the unit test, API test, things that are early in the process. You think about those, these are important for us. Let's see where we can fit this. And especially if you can automate them, it's very easy to push them to the left. And that's cool, but most of the time, that's not the case for the non-functional stuff. So we need to do some kind of translation. So what is this translation? When we're doing testing, any kind of testing, almost all kinds of testing, unit testing, maybe even sort of an exception here, but even that falls into this thing. I gave you an example that if a code has a security vulnerability, it will probably go with it into production. That's true for unit tests as well. For example, you're checking a function, your test passes. What are you doing really? Say, well, this bit of code will run in production eventually, and it's passing now, so that means that it will probably work in other stages as well. This is what we do in our head. Like, this is why we have stages of testing. Whatever you're doing in terms of stage testing, like API tests or web tests, whatever you're doing in your process, in your pipeline, manual testing or exploratory as well, what you're doing is testing in an environment which is not completely like a production environment, and you translate what you see. This work in staging environment with one database, it will probably work better with, it will probably work in production when we have 500 servers and 4 databases. You do these calculations in your mind, in the team, it doesn't matter, but you almost never you cannot always, most of the time you cannot replicate the production environment on your stage. So there is some kind of translation. So in our context, we don't have everything that runs in a production environment. So we're trying to like sort of simulate an environment in which we can look at the results and translate from that what we're going to do at the end. So performance, for example. So you want to simulate 1,000,000 people calling this API. You can run this. Will this happen the same in production? The answer is probably not. Like we can create like a sandbox when we're doing all these kind of tests. We have to first translate it. What is the probability that this will actually look like this in production? So obviously it will not work the same way. Some of the things we can do on certain, or maybe it's a scale, or we say, at least this has to work. You kind of set up a low benchmark and you say, well, this has to work for a load of 1,000 users, concurrent users. Okay, so if it doesn't work, that we have a problem, we can't release. So you can do these kind of things in your pipeline for load, for even things like we talked about responsiveness, robustness, fault tolerance, things that you can check before releasing. And you can say, well, this is like this is where we are. Maybe with this kind of load, we can't, this is good enough, at least for moving this into production, or maybe this is not good enough. We haven't passed the lower benchmark. Even think about security, not at the code level. You have like configured a system that is a staged environment for testing. It could be a pre-production thing, like the final stage before or something else. And you can, with enough expertise, try to enter the system, grab data from the system, all kinds of security hacking, play with that. And again, you'll find that this is something that is either acceptable to move to production or not. This is where we're already talking about we need to understand what we're doing. It's not like the tools will tell us if we were wrong or right, because yes, tools are helpful. They take a lot of the load, the mental load of understanding things. It's either we pass the checklist or not pass the checklist, but we can actually do something about it. Here we're talking about we need to understand what we're doing and how this translates to the production. Final thing we can actually, when we do that, test in production, because this is like the real environment that we can actually look at. Some of the things are simpler. Of course, it needs to be a lot safer because there's people actually using this system right now while we're testing it. So we need to do this in a different way. And there are different ways to do this. If you think about like A/B testing, or ABC or whatever, it's sort of testing in production, right? You're testing usability, maybe usefulness, usage, and the responsiveness of the system in production is actually tells you this is how it actually behaves. So things like performance and efficiency. We talked about energy efficiency, CPU cycles, whatever. This is how it's going to work like in production, because this is how it actually works. So some things are not transferable from pre-production or early stages. So some things you actually can check in production. And again, it's the same process. You need to understand what you're looking at, what you're measuring, look at the result and say, well, this is where we are, this is what we want to improve. Obviously, there are ways to improve that as well. And probably most of you have heard about something called chaos testing. It originated in Netflix when they very controllably drop servers off the map. And what they're testing really is sort of a disaster recovery, but they check both how the system reacts and adapts and how the organization reacts and adapts. So it's a whole thing. Obviously, it's controlled. If something goes completely wrong, it needs to be reversible. And you need to actually think about, well, if I turn something off in the middle of something like a payment, what happens? So obviously, very controllable. But a lot of the things happen in production. So you can't really translate that. When it's possible, you can. Want to mention one, not you, yeah, you. The things that we talk about at the beginning, like scalability and availability and stuff like that. kind of fall off into the DevOps section, and these are the people who have the expertise about these things. So we kind of, if you have like a DevOps organization in your organization, this is where the expertise and skills and where you will turn to in order to facilitate this kind of testing. You need to set up system in order to check different things. You need to see what you're looking at, in order to measure stuff. And if it's not, somebody will have to help you expose the measurements that you want. And usually this happens the DevOps section of your organization. So everything around scalability, and there are things like configurability and deployability. Some of them I think are invented words. Recoverability, supportability. Think about this, like this is a non-functional topic. How well can you support the users? It's interesting. It could be like a lot of money in that. If an organization says, well, this is important for us. So a lot of these things, you probably have already the expertise in some way. You kind of need to work with DevOps in order to define, well, this is what we're going to do, this is what we want to learn, and this is how we're going to do it. And chances are these are the first experts that you do have in your organizations when handling that. For the things that you can run inside the development, usually inside the pipeline, stuff like that, maintainability, extensibility, all the things that are code specific, clean code metrics, complexity, size of code, things. There are tools for that. Again, and tools that scan the code and can tell you where you are. Sometimes they don't tell you exactly. I'll give you an example. A few years back, I looked at the rules for Java in SonarQube. So it comes with a bunch of 300, maybe more today, of rules and metrics that tells you, well, is your code okay or not? And if you look at the complexity, they have their own type of complexity, which checks branches in the code. And I think it was like 12 or 13 branches. And this number means that if it's above this 12 or 13, you can actually fail build for that. If there's somewhere in the code that has 13 if and else's, it will break. And if you think about it, like 13 is a lot, like 5 is a lot. You probably want to break a lot earlier if you actually want to do this. And that means that it's not like you can drop everything or the responsibility on the tools. Again, you have to understand, you have to apply these things to your situation. So there are tools for that as well. And of course, you can check those out as well. With those things, there's a lot more expertise about integrating those into the development process than the other stuff that are not tool-based. So again, I'm going to start to summarize these things. When you're going into this new thing that you're going to test, it's not going to be completely understood what you're going to do there, what is important, what you need to look at, what you need to measure, and what these measurements mean. You have to have this kind of expertise. It kind of takes time until you actually build this expertise and document it and build the entire support system inside the organization in order to facilitate this, not just for one stop, but over time. I didn't mention it. A lot of organizations do like load testing or security testing, not on a day-to-day thing, but every few months. And this is like their regular schedule. When they do, maybe they bring experts from the outside and they're doing some kind of performance testing. And the reasoning behind this is we don't need this every day. We have decided that this expertise can be brought inside once 3 moons, and that is okay for us. It's a knowledge management methodology, which is okay or not okay. and then you spend like 3 days hacking the system or whatever, and you get the results, you get a report, say goodbye, let's see you in 3 months, which may work for you or not. So you need some kind of strategy of how you're going to deal with it, how you're going to develop this expertise. How do you prioritize this stuff? Within the expertise, okay, it's once you understand what you're doing, you can define what is important for you. Sometimes it's not. Well, if you need to compare security versus performance, who's going to be the judge of what's more important? And when you go down a level, what kind of things in security and performance, like how do they compare to each other? Somebody needs to prioritize this stuff. Again, it's going to be hard because we don't have the expertise. We need someone to tell us this is important for us. Somebody will have to take the decision and the cost with it. Usually it starts out when you're learning where you are once you decided, well, this is what is important for me. And then you build your improvement plan, if at all. Sometimes you'll be surprised that you're already working according to something, and then you can move on to something else. Because as we've seen, there's a lot of them. Sometimes it's going to be easier because you're in a regulated market, and the market tells you, you need to support this. And once you do, there's probably going to be a rule set, and there's going to be a checklist. And won't say it's going to be easy, it's going to be simpler than like starting researching everything. So obviously it's not really fun doing regulated stuff, but sometimes we have to. And it's going to be simpler when you have this kind of direction. Obviously, the more things are regulated, you'll find more experts about this. And you also find certification and stuff like that, which I'm not going to talk about today. But it's easier to implement things that you have to, because once you have to, that means there's been a process of translating what needs to be done into some kind of checklist. If it's not, you have to develop this on your own or by getting experts in and trying to formulate what is important for your organization and your team. Once you do that, you look at what you want to measure, and the final thing is you probably develop a sort of a pass-fail criteria. This is good enough, this is not good enough, this is where we want to go, and try to change your plans according to where you want to be. I started with Vizini, I'm going to finish with Wesley here. You can't really be an expert in everything. This is kind of a problem. Small problem, a nice problem to have, but it's not easy for someone who tried to learn everything like early on in my youth and still have the capability to do this. You can't really be an expert in everything, and that means that in your day-to-day job, when you're entering these kind of things, you can feel first the need of the organization. Where are we going to be working on? What is interesting to me and what is interesting for the organization? So, and try to see where you fit, what interests you, and so on. I want to mention that because there's not enough people, experts on these, it's an opportunity. And even if you're not like a super techie or stuff like that, there's enough area for you not just to grow, but like to become this expert. And like I said, there are not a lot of experts on these things because we're still learning these things. So even the expertise is not like talking 10 years. We security, we're running forward with all kinds of technologies and two-factor authentications and passkeys and other vulnerabilities now. So there's a lot to learn. There's a lot to be expert on. And once you get expertise, and the cool thing about testing is that it's not just you know what needs to be done. You actually run experiments and run tests on that. So you actually can check how things are done and look at results, look at different systems and how they react to this thing. And it's not just it saves my data or not. And so there's a good opportunity, a big opportunity here to become an expert. It's good for your experience and your career as well. So we talk about T-shaped testers sometimes, like you have like one expertise. You can have more than one, but not a lot. So try to see where you actually want to fit this kind of thing. If you stick to the functional, not you can be an expert in the things that you're actually doing. It's sort of like product. You can be a product expert and so on. These things, the non-functional stuff, are a lot more transferable than application stuff, because apart from people looking for this kind of knowledge, when they're missing this in their organizations, there are really cross projects. So if you think about it, you compare like the functional knowledge like this. The non-functional knowledge is this. It's a lot bigger, and it requires like we say, well, kind of a put the glasses on, because if we kind of in the beginning we kind of blind to all these things that around the functional stuff, but there's a lot more there, and you can find what's interesting for you. These are big topics. These are very deep topics. You can be different kinds of knowledge and activities and testing that you can do. Find the tools that are working in this area. Find what you can't really do. Find what you need in order to set up these things and test them. So there's a lot of things around this non-functional stuff. And you can see in the picture, the car may still work. Is it fun to ride? Not. So that's the non-functional stuff. It is important. And you can see by the regulation stuff, things are becoming important. Because this is usually where when governments say, well, this should be regulated, this usually means that this is very important enough or has a lot of money in it. So both are good in terms of what we're doing career-wise. And there's a lot of things that can be learned, a lot of things that you can find that are interesting, valuable for you, for the organization, and stuff like that. And that's what I wanted to share with you today. Follow me on all the things that you see on the screen. The YouTube channel is where I put these kind of webinars, the recordings, and short videos as well on all kinds of things of testing and development, usually every Wednesday. Thanks for coming and listening, and I hope you got some kind of value from here. If not, I hope you like the memes too. See you in the next webinars. Probably going to be in a less hot environment. Until then, bye-bye.